Hey guys, welcome to the notes for evaluating functions. We are in Unit 2. Our essential question is, how is the language of math communicated? So briefly at the beginning of Unit 2, we talked about what a function is. And there's two types of tests to determine if something's a function. We have the test of a vertical line test. When we have a graph, we want to be able to draw a vertical line, and that graph that we have can only pass through the line one time. If it passes through it more than once, then it's not a function. The other test that we know is that if there are repeating x values, it is also not a function. So your x values can only have at most one y value. So let's review about the definition. So for every input, anything I put into my function, there can be at most one output. So if I put something into a function, the most I should get out is 1. Sometimes I get out nothing, but the most I get out is 1. Now, function notation is basically just a different way of writing equations. So, for example, we normally have something that's like y equals 3x. Well, when I'm asked to write in function notation, I have to write it as a function. So I would write it and make this fx, or f of x, equals 3x. So the only thing I'm changing here is that I'm changing my y value and changing it to an f of x. But they mean the same thing. So it still means output, still means range, still means all of that. It just looks a little bit different. It's just in function notation. Because if I have a bunch of equations that start with y equals, it's hard for me to tell them apart. But if I have an f and a g and a t, I can tell those apart by the variables that they have. So down here I have something where it has f and the parentheses with the x is read as, so the way you say that is f of x. So if I have an f and a parentheses x, it's going to be f of x. So if I had, let's say, g and an x, it'd be g of x. Or I could have t of x. Or I could have r of t. So it's just the way you pronounce it is really the only key thing right there. Then we have an input and output table. So these are kind of the differences between an input and an output. So an input is something you put into a function or into an equation, and that's usually your x variable. So your output is usually your y variable. Okay? Now your x variable is also known as the independent variable, and the y is known as the dependent. Okay? The x values are also known for being called the domain, and y is also being known to be called the range. So this is nothing new. Like this table that we've created, this is stuff that we've talked about. X is always associated with domain, and x is always independent. Y is always associated with range, and y is dependent. But now our input is going to be considered an x value. So if it asks you to find the input, it wants you to find the x. If it asks you to find the output, you're going to find the y. Okay, now I know it looks really scary at first, but once we get through this, it's going to be really easy for us. So let's go ahead and talk about this. Given f of x equals negative 2x plus 5, g of x equals 2/3 x minus 1, and h of x equals 3x squared plus 2x, we need to find three values. We need to find f of 4, h of negative 2, and g of 6. Now this is a lot, but this is three separate problems. So I'm going to go ahead and draw a line down the middle for each of these to separate these problems. Okay, I'm going to draw, what's happening up here? Okay, I'm going to draw a line better, a better line, not a line better. Okay, so we're going to do the first problem, f of 4. Now, if you look up at the top, there are three different functions. We have f of x, g of x, and h of x. And for our number 1, 2, and 3, it'll use a different function depending on what it's asking for. So for this first one, it says f of 4. So I'm going to look up there and look for my f function, which is this first one, f of x. So I'm going to go ahead and copy this one down, because I know I need to be the f function. You want to match it with that one. Okay? Now, if you notice, if you look, the 4 is in place of what variable? What variable normally goes here? Well, we replace the x with that 4. So essentially, it's telling us to do, hey, let's plug in 4 for our x value. So I'll have negative 2, and I want you to be very careful. Anytime that you are substituting a number, anytime you are plugging in a number, you will use parentheses. Make sure you use parentheses. So I have negative 2 times 4 plus 5. Okay? Now, the only thing I did here was I took my x value and I plugged in a 4 because, well, it's saying that my x is 4. And then after this, I'm going to simplify. Negative 2 times 4 is negative 8 plus 5. And then negative 8 plus 5 is going to give me negative 3. So essentially, what is my answer? Well, there are a couple ways we can write this. We could write it a couple different ways. So let's go ahead and write it one way. Here's one way. We could do f of 4 equals negative 3. So we said find f of 4. Well, I did. It was negative 3. So this is one way we could write our answer. Another way we could write our answer is also writing it as an ordered pair. Well, earlier it said that x was 4, right? Because it's in place of our x value here. So it would go 4, and then if we were given the x 4, then what we found was our y value, which was negative 3. So there are a couple of ways to write this. I prefer the first way, but either way is technically correct. You won't really see it the second way that often. Okay, let's go ahead and do the next one. So we're going to do h of negative 2. And you want to look at all of your functions and be like, which one of these is associated with this one? It's going to be this last one because it's the h function. You want to match the functions with their letters. So you got to be super careful about picking the correct one. But it's the only one that has the matching variable. Okay. So, if I look, my negative 2 is in place of what value? My x value. So x equals negative 2. So anywhere I see an x in my h of x function, I'm going to plug in a negative 2. And when I plug it in, I always use parentheses. Okay? So if you look, and the only difference is that instead of the x's, I now have numbers in for them. Okay. The next step here is to go ahead and simplify. So you always want to do PEMDAS. So it says parentheses first. Well, there's nothing inside these parentheses I can simplify. So the next step is exponents. Well, I have one exponent, so I'm going to do 3. And then negative 2 squared is going to be positive 4 because negative 2 times negative 2 is a positive 4. And then I also have 2 times negative 2, which gives me a negative 4. Equals 12, because 3 times 4 is 12 minus 4, and this equals 8. Okay, so again, nothing new. You're just substituting in your variable, or you're not your variable. You're just substituting the variable with a different value, and it's whatever value that they asked you to put in or input. So our input was negative 2. Our output was 8. So let's go ahead and fill this in. So I can say that h of negative 2 equals 8, which in different terms means if I input negative 2, I'm outputting positive 8. Okay. And then the other way to write it is that if my negative 2 was the x value, then my y value must be the 8. All right. All right, the last example on this part. Okay, so this is evaluate for g of 6. Well, which one of these is the g function? It's going to be the one in the middle. So g of x equals 2/3 x minus 1. So always be super careful which one you're deciding to use because you have to make sure it's the correct one to use. All right, what color have I not used yet? I use this lilac color, I suppose. All right, so this says that I want to input a 6 for my x value because instead of 6, it is now an x, or instead of x, it's now a 6. So we have x equals positive 6. So anywhere I see an x in my function, I'm going to plug in a 6. Okay. That's going to be 2/3 times 6, which is going to be positive 4. And then I have 4 minus 1, which is going to be positive 3. So my answer here is going to be that g of 6 equals 3, or 6, 3, because 6 was my x value. All right, so those aren't too bad. You just have to make sure that you're inputting it in for the right function. All right, the second problem, we have evaluate the function k of x equals 7 minus 2x squared with the given domain -3, 0, 6. So it wants us to evaluate the function. Well, evaluate just means solve. So don't get super scared out by these big words. And function just is an equation, right? You want to solve the equation. And you're like, oh yeah, I know how to solve an equation. I can do that. So we're going to solve the function k of x equals 7 minus 2x squared. And it gives us a domain. Remember, domain is what values? It's your x values. Okay? Domain is associated with our x values. So it's giving us 3 x values. It's giving us -3, 0, and 6. So let's go ahead and separate our workspace here. Okay. Now, remember, domain is our domain are our x values. So the first x value they provide with me is -3. The second x value they give me is 0. And the third x value they give me is 6. Now, I'm saying x equals because it's domain. If it were to give me the range, I would do the opposite and say y equals. Okay. So we have k of x equals 7 minus 2x squared. So I'm going to go ahead and copy down my function here. Now it's saying x equals -3. So I'm going to input a -3 where I see an x. I don't know why I changed colors. So I'm going to have 7 minus 2, and I'm going to input -3 for my x value here, and then I'm going to keep that squared. So again, you're inputting your x value to be -3. Why? Well, because we have x equals -3 here, and also its domain, which is x values. So here we're going to have 7 minus 2. -3 squared is +9. And then we have 7 minus 2 times 9, which is 18. And 7 minus 18 is -11. Now, we don't want to go ahead and box our answer yet, but I will go ahead and make sure I'm going to circle. So I'm going to keep it circled for now. It isn't my answer, my final answer, okay? But we do want to keep it in mind. All right, so our next one, we have a value of 0. So you're going to do the same exact thing, except when you plug in for x, it's going to be 0. So it's nothing different from the first one, except you're plugging in a 0 instead of a -3. So you have 7 minus 2. Well, 0 squared is just 0, so that just stays 0. And then -2 times 0 is just 0, so that just goes away. So all we have left is 7. So I'm going to go ahead and circle 7. Oh, that's an ugly circle. Okay. And then the last function, or the last example, not function, input value, we have x equals 6. So you're going to do the same exact thing, but instead of plugging in any of the other numbers, you're going to plug in a, oops, I need green. You're going to plug in a value of 6 for your x value. Okay, 6 squared is going to be 36. Now, 2 times 36, or -2 times 36, is going to be -72. And 7 minus 72 is -65. Now, here's the reason why I circled all my answers and I didn't do much else with them. Well, do you see how at the very beginning, it gives us domain, and it gave it to us in little curly braces with -3, 0, and 6. Well, we're going to give it back to them also in curly braces. So my answer here would be that my range is going to be -11, 7, -65. It's whatever I got for my 3 evaluations, right? So it says, hey, I gave you these x values, give me back some y values. So you're giving the y values back as range, and you're giving it as -11, 7, and -65. Okay, now these last 2 problems are problems we miss super a lot, I guess. Or we miss it all the time, and it's because we get in this habit of just, oh, plug everything in for x, plug everything in for x. But it is super important that you read and understand what is going on. So we're going to go ahead and take these a little slow. Find the value of x when g of x equals 4x minus 2 and g of x equals 18. Okay, it wants me to find the value of x. So I am solving for x. Okay, I'm solving for a variable. Okay, we'll go ahead and copy down my equations here. I have g of x equals 4x minus 2, and then I have g of x equals 18. Well, looking at the smaller one, it says g of x is 18. So this is g of x, and it equals 18. Okay, well, do I see g of x on the other side anywhere? Yes, I see it right here. What does g of x equal? It equals 18. So I'm going to substitute the entire thing for 18, and I'm going to solve for x. So you're not plugging in for x here. That is the habit that people want to do. They want to plug it in for x, but you're not plugging in for x here. You're going to be solving for x like an equation. So go ahead and draw my line down the middle. We're going to add 2 to both sides. Okay, and the next step I would divide by 4. Okay, well, did it say to find the value of x? Yeah, and did I do that? Yep. So my answer is x equals 5. Now, what was different about this problem? Again, you are not going to take 18 and plug it in for x. You are replacing g of x with 18. You're replacing all of it, okay? Not plugging it in for x. All right, so number 2 is another example of this. Given p of x equals x squared plus 3, find x if p of x equals 39. Okay, p of x equals 39. It equals that. So this now goes away in the p of x, and that becomes a 39 because it says p of x is 39. So I'm going to go ahead and replace it. I'm going to plug it in for p of x. And this will be equals x squared plus 3. Okay? Now it's solve for x like normal. I don't want to use red. Let's use purple. Okay. Now you're probably wondering, well, how do I get rid of that square? Well, remember the opposite of a square is a square root. So if I have a square root of one side, then I square root the other side. And when I square root, it cancels my square sign, and all I have left is an x. And the square root of 36 is 6. Now, why is that the square root? Well, 6 times 6 is 36. So like the square root of 25 would be 5, because 5 times 5 is 25. So that means the number times itself will give me 36. So that means 6 is going to be the square root of that. However, there is one more answer. You also have negative 6, because negative 6 times negative 6 is also positive 36. Whoa. So you're going to have 2 answers here. Okay? X equals 6 and x equals negative 6. All right. So that is it for these notes. If you have any questions, please feel free to come in and ask.